quick little review of Newton's 3 laws of motion. So our first law, an object stays in motion or an object stays at rest until an outside unbalanced force acts on it. And we call this the law of inertia. So you can see the little test tube guy scooting along. Some outside force causes his skateboard to stop, but doesn't cause him to stop. His inertia is what keeps him moving forward until gravity finally takes him down. So what this does not mean, all objects naturally come to a stop over time. That's not true. That doesn't happen. Objects move with a constant velocity when they have a constant force acting on them. Also not true. When objects are able or have an outside force acting on them, like this little guy here, if I apply a force, if I just tap that arrow key, then he scooches along with a tiny little force. If I hold down the arrow key, see how he accelerates, okay? And then if I tap that again, I can get him to stop. Tap it once, and he'll scooch along at a constant velocity. He doesn't ever slow down. But if I hold it, then he will accelerate, okay? So that is a key thing about first law. Unbalanced forces cause objects to either speed up or slow down or change direction. Otherwise, they're going to keep moving or keep still because of their inertia. Second law. Okay, a bigger force means a bigger acceleration, or a bigger mass means a smaller acceleration. So for example, if we apply the same amount of force to a bowling ball and a soccer ball, the soccer ball is going to accelerate more because it has less mass. What it does not mean is that a bigger object can exert a bigger force on a smaller object. That's not how that works. If those two balls, if the soccer ball and the bowling ball did collide with each other, they would have to apply equal and opposite forces to each other. The bowling ball can't apply any bigger force than the soccer ball can apply back on it. If the bowling ball hit another bowling ball, then that force between them would be bigger. But if it's the bowling ball hitting a soccer ball, it can't hit it as hard. So equal and opposite forces between any two objects that collide. Okay, and that leads us right into third law, which is all forces come in equal and opposite pairs. So it's like what's going on in our first image here with the equal and opposite forces. The force of the foot on the ball is equal and opposite to the force of the ball on the foot. And that is exactly what's going on here with the test tube guy hitting the soccer ball. The soccer ball also applies a force to his foot, but it's just not a very big force because he's got a small mass. The soccer ball, has a small mass, smaller than the test tube guy. When the test tube guy kicks the wall has a much bigger mass. And so the test tube actually feels a much bigger force. But the wall can't hit his foot any harder than his foot hit the wall. It's still equal and opposite. Okay, so what this does not mean, what's not true, is an action causes a reaction. That's not what we're trying to say here. It's equal and opposite forces occurring at the same time. And then when you kick the wall exerts a bigger force on your foot. Not true. The wall can't exert a bigger force than what your